differentiate. When we have a constant term, the differentiation or the derivative of that is just going to be 0. So that's always going to be the case. When you have a constant term, the derivative of a constant term is 0. If I have just a letter, so x for example, the derivative of x is really, we can think about this as the derivative of x to the exponent 1. And I know that's hard to, sometimes tell the difference between. And when we find the derivative of a polynomial function or a power function, we take the derivative when we take the derivative, we take the exponent and we multiply it out front, so 1. And then we take the base of the x and we subtract 1 from the exponent. So 1 minus 0, or 1 minus 1. And we know that 1 minus 1 is 0. So that becomes 1x to the exponent 0. But anything to the exponent 0 is just 1. So it would really be 1 times 1, which is just 1. And so that's an important thing to remember as well. So if we just have a letter or a variable all by itself, the derivative of that is going to be 1. Now what happens when we have x to the exponent 5 and we want to find the derivative of that? So in a similar vein, we're going to take a look at the exponent. The exponent is 5, and we're going to multiply that out front of the term. And then we're going to take our variable, and we're going to look at our exponent, 5, and we're going to subtract 1 from that. So then this becomes 5x, and then to the exponent 4. And so this is how we take the derivative of a power. Anytime you have a rational expression, remember that you can write this as an exponent with a negative. So instead of writing 1 over x, I could write this as x to the negative 1, and I want to find the derivative of that. So how do I do that? Well, I follow the same rule as I did with the power function up here. So I'm going to take my exponent, negative 1, and I'm going to multiply it by my term. And then I'm going to take my exponent, negative 1, and I'm going to subtract 1 from that. And that's going to give me negative x to the negative 2. Now I can keep it like this, or I can now rewrite this as a rational expression. So anytime I have a negative exponent, I could write this as, I can't figure out my negative, so 1 over x to the positive 2. And so the same thing would apply for any rational expression. So I can go ahead and rewrite this as x to the negative 7, and I want to take the derivative of that. So I'm taking negative 7, multiplying it by my variable. I'm looking at my exponent. I'm subtracting 1 from that. So that gives me negative 7 x to the exponent negative 8. But I can write this as a fraction, keep my negative 7 in the numerator, but move my negative exponent to the denominator so that it becomes x to the exponent 8. When I have radicals, I also know that I could rewrite this as an exponent. So anything that is under the square root has an exponent of 1/2. And I'm going to follow the same power rule as I did for the previous ones. I'm going to take my exponent, multiply it out front of my term, so 1/2 x, and then I'm going to look at my exponent 1/2, and I'm going to subtract 1 from that. So I get 1/2 x, and then if I take 1/2 and I subtract 1, I get an exponent of 1/2. Well, what does that mean? Well, I could rewrite this as 1 over 2 x to the 1/2. The 2 goes in the denominator as well. And then instead of writing it as a rational exponent, I could write this under a radical sign, so 1 over 2 root x. And I can follow very similar steps for each of these radical exponents. So I could write this instead of the cubed root of x, I could write this as x to the 1/3, and then follow the same steps as I did before. So 1/3, because that's my exponent, multiplying out front, x, and then 1/3 minus 1 as my new exponent. This becomes 1/3 x, and this will become negative 2/3. And when I have, again, a negative exponent, I can write this as a fraction. 1 is going to be in the numerator, my 3 is in the denominator, and my x to the 2/3 now is in the denominator. But instead of writing this as a rational exponent, I could write this as a radical. So this is going to be 3 and the cubed root of x squared. This next one here, I have the 4th root of x cubed. I can rewrite this as an exponent, 3/4, and now take the derivative of this expression. So take my 3/4, multiply it by the term, and then take my 3/4 as my exponent and subtract 1. That gives me 3/4 x, and then 3/4 take away 1 is negative 1/4. I want to write this as a positive exponent, so 3 in the numerator, 4 in the denominator, and this is going to be x to the 1/4. But instead of writing it as a rational exponent, I'm going to write it as a radical. So 3 in the numerator, 4 in the denominator, and this is the 4th root of x. And lastly, if we have an exponent that's a pi or something else, again, don't be afraid of this. This is going to be, the pi is our exponent, so we're multiplying it out front. So pi, and then x, and then I'm going to take my exponent pi, and I'm going to subtract 1. And I can keep it like that. I don't need to, approximate that as 3.14 minus 1. I can just keep it as pi minus 1 for now.